Modern instructional design is often driven by corporate deadlines and stakeholder mandates. We hear directives demanding that all videos must stay under 5 minutes, or that complex compliance training must be delivered as a podcast. These demands are frequently packaged as industry best practices. In reality, these are professional dogmas, rules often at odds with the science of human learning. When digital learning ignores cognitive science, it actively works against the brain. It forces the learner to fight the format instead of absorbing the material. Our brains operate under strict physiological constraints known as cognitive architecture. This biological framework dictates exactly how we encode, store, and retrieve data. To build effective training, we have to look at the empirical data across text, images, audio, and video, and dismantle 4 deeply entrenched e-learning myths. Relying on measurable evidence over popular trends allows us to construct learning experiences that actually secure knowledge. True instructional design requires aligning the delivery of content directly with human cognitive capacity. Let's start with text. There is a persistent assumption that reading on a screen is identical to reading a physical book, where sustained, deep concentration is the natural default. But the first digital environments revealed that moving text behind a glowing screen triggers a distinct behavioral pattern in the human brain. While some studies show reading speed might increase digitally, comprehension frequently plummets. When faced with digital text, humans inherently shift from reading to scanning. This scanning behavior is dominated by the F pattern. The eye tracks across the top left, absorbs the first few lines, then rapidly degrades into a vertical scroll. Dense text results in comprehension gaps. Entire paragraphs in the lower right go unread and unencoded. The empirical solution is structural signaling. By introducing bullet points, bolding key terms, and isolating critical concepts, we interrupt the F-pattern scan and force the brain back into deep reading. This is also why external hyperlinks degrade learning. Clicking away from the page forces a context shift that disrupts focus. Definitions must remain in line, right where the learner needs them. Taking an analog document and pasting it onto a web page guarantees cognitive failure. Digital reading requires deliberate structural scaffolding to capture and hold human attention. We often hear requests to strip out images from training materials to avoid distracting the learner. Alan Pivio's dual coding theory proves this demand is scientifically invalid. The brain has 2 parallel pipelines, one for verbal, one for visual data. Relying only on text creates a bottleneck. Engaging both simultaneously increases bandwidth. Verbal and visual data merge in working memory, forming a highly durable, encoded concept. This is precisely why we use instructional images. Describing a complex mechanical sequence using text alone requires massive cognitive effort. An image concretizes the abstract instantly. But this raises the question of decorative images, visuals included entirely for aesthetic reasons with no direct instructional value. Conventional cognitive load theory suggests these decorative elements distract the learner and consume valuable processing power. Recent studies show the exact opposite. Positive, aesthetically pleasing images can reduce perceived cognitive load and increase overall performance. The mechanism here is emotional. A visually appealing layout induces a positive emotional state, which reduces cognitive resistance and increases the efficiency of information processing. Visuals serve as critical load-bearing structures. They enable parallel processing and help regulate the learner's psychology. Next, we have the audio lab. Corporate training has seen a massive surge in podcast adoption, largely driven by low production costs and mobile convenience. The physiological limitation of an audio-only format is that it relies entirely on a single processing channel, bypassing the visual encoding pathway. A large-scale study out of Australian universities tested the efficacy of podcasts across hundreds of higher education students. The results showed 0 significant improvement in primary exam scores for students relying on the podcast material compared to those who didn't. Without visual anchors to map the data, the brain struggles to hold on to complex theoretical concepts or mechanical processes. The data shows audio is highly effective in 2 specific scenarios, as pre-learning to prime a student or as post-learning for review. It is ineffective as the primary vehicle for deep knowledge transfer. Audio formats feel engaging, but their lack of multimodality makes them a weak tool for teaching foundational, complex skills. Finally, we arrive at video, the ultimate multimodal tool. delivering visual, auditory, and kinetic data simultaneously. The first misconception we need to clear up is the acceleration myth, the assumption that watching a training video at 1.5 or 2 times speed degrades comprehension. Recent empirical studies out of the US and China directly contradict this assumption. This chart measures retention against playback speed. Accelerating to 1.25 or 1.5 actually increases focus. This acceleration matches the brain's processing speed, preventing wandering. Efficacy only drops sharply approaching 2.0, where cognitive overload sets in. The second major misconception is the ideal length myth, the arbitrary mandate that all learning videos must be strictly constrained to 5 or 10 minutes. A massive review of 105 independent studies confirmed there is no universally validated ideal duration for an instructional video. Efficacy relies on segmenting the content logically and allowing the user to control the pacing. Arbitrarily limiting video length or forcing standard playback speeds artificially constricts the learner. User-controlled pacing is what the empirical data demands. When we zoom out and look at the entire spectrum of digital modalities, a clear picture emerges. Historically, education relied on a uniform delivery model, often ignoring individual cognitive nuances. Today, digital tools allow us to construct a dynamic instructional matrix, plotting our delivery methods against content complexity and multimodal engagement. Text is highly efficient, but it requires deliberate digital signaling to survive the brain's natural F-pattern scan. Images activate dual coding and help regulate learner emotion, while audio serves best as a primer or a review tool. Video handles the highest levels of complexity, provided we segment the information and grant the user control over their speed. These empirical insights give you the defensive shield you need to push back against arbitrary stakeholder demands and outdated assumptions. True instructional design is a flexible, evidence-based science dedicated to aligning content perfectly with the architecture of the human mind.